Hello, everyone, and welcome to today's webinar, Improving Chiller Maintenance Using Internet of Things and Predictive Technologies. I'm Ann Cosgrove, the Editor-in-Chief of Facility Executive Magazine, and this webinar is presented by Johnson Controls. Before we get started, I'd like to cover a few housekeeping items. Please note the control panel that's on your screen. This is where you can submit questions in the question box in that panel. You can send those questions in for your speakers at any time, and they will be addressed after the presentation. Also, please note the orange arrow on the left side of your control panel. Clicking on that arrow will either expand or collapse the panel, so please be sure that is expanded so you can access the question box. Also, if at any time you experience a technical difficulty, you can also send a message to us in that question section, and we will address it right away with you privately. Now I'd like to introduce your speakers today. David Bishop is the Director of Service Operations for Johnson Controls, representing Systems and Services North America. Dave works for the Building Efficiency Business Unit of JCI that offers customers expertise in how to make non-residential facilities perform better. He currently leads the North American field service business in the development of operational strategies to improve safety, customer satisfaction, and productivity. He is a graduate of Auburn University, and during his 37-year career, he's held various regional and national leadership positions in Alabama, Southern California, and Georgia prior to moving to Wisconsin in 2002. Juliette Pagliaro-Herman is the Director of Service Marketing and Product Management for Johnson Controls Systems and Services North America. And prior to this role, she served as the Product Manager for Planned Service for North America and as Program Manager for Energy and Sustainability for Johnson Controls globally. Before joining Johnson Controls, she worked for General Electric Healthcare in various roles, and she has a Bachelor of Science degree from Northwestern University. We also have a special guest today, and that's John Kukler. He's Manager for Predictive Diagnostics at Johnson Controls, so John will have a good deal to offer as well on the topic. He runs the predictive platform of technologies for the company worldwide. So with that, we'll get started, and I'll hand it over to David. Hi, David.
Hello, thank you very much for that introduction. Appreciate that. And good morning and good afternoon to many of you out there. We're really glad to have you all on the call this morning. Our agenda for today, I want to cover that first. We want to talk a good bit about challenges in operating chiller plants, costly reactive approach to maintenance, how predictive Internet of Things technology can help you, methods of fault detection and diagnostics, corrective, proactive approach to chiller maintenance, and how you optimize chiller replacement decisions. And then at the end, we will hope to have a few minutes to have a summary and then take your questions. We really love to hear from you. So starting out, we like to show this slide from time to time, which really reflects what a facility manager goes through. And many of you on the call may be a facility manager. If you're not a facility manager, you might work for one, or you may be a contractor that's been in and out of a building working with facility managers. But if you're in that job, it's a busy job. There's many challenges. You got a lot to deal with. If you think about it, day to day, you've got contractors and suppliers that you have to qualify and get in and out of the buildings. You got your in-house team. You got to manage your people, right? So you've got that task to be involved in. We always talk about reporting up. I think just about everybody has executive management you have to report up to. And then how could you not think about the regulators, how important regulators are? They literally can shut your business down in many, many cases. And then what should be the most important thing that you deal with as a facility manager is your occupants, your customer, and if you could just get more time to take care of your customer, I'm sure that would bring value to many of you out there. So we talk about in this session, how do you deal with emergencies? Are you dealing with them or are you avoiding them? And we'd like to submit that it's a lot better to avoid emergencies than it is to deal with them. And so we're going to spend a good bit of time about how you can become more productive by using different technologies and different tools in running facilities that have chillers in them.
Okay, so Dave, this is Ann again. I believe we do have a poll now before we get on to the next section. There it is. Okay, and we'd like to ask you all out in the audience to take a moment to vote on this question. And that's what keeps you and your facility managers up at night when it comes to maintaining your chilled water plants. And as you'll see, please select one. Is it recording and accessing the operating data? Is it troubleshooting problems, responding to occupants, managing vendors, keeping up with plant maintenance? So select the one that keeps you up the most at night. And we'll show those results on the screen in a few moments. Thank you. Okay, so what keeps your facility managers up at night when it comes to maintaining chilled water plants? Our leading concern in the audience here is keeping up with plant maintenance, 48%, followed by troubleshooting problems, 27%, responding to occupants, 17%, and then recording and accessing the data and managing vendors following up. So thank you very much for taking the time to share that with us. Back to you, speakers.
Excellent.
Great.
You know, Dave, I think that's pretty consistent with what we've heard from our customers too. Keeping up with maintenance, responding to emergencies, and here's some reasons why. You know, there's a lot of downside when you have problems and you have these emergencies. And so studies have shown, for example, that you know, the decision to correct a problem can often take 20 times longer than the actual repair itself. And many of you have probably experienced this, where things have to go up and down the food chain several times before you finally get the approval to actually correct the problem. In addition, emergency repairs are exponentially more expensive than planned work. So if you can get on top of the maintenance, you can often avoid those costly emergencies that, you know, we always say a planned corrective action is going to be less expensive and less disruptive than an unplanned emergency. And finally, you know, when you invest in maintenance, that can help get more out of your capital dollars. And if you don't invest in maintenance, studies have shown you can spend up to 4 times as much on premature capital renewals than you would have if you had just put those dollars towards proper maintenance of the equipment.
You know, Juliet, you talk about, you know, the high cost, and, you know, I think what I'd like to do here is just kind of give you an example of a long and costly reactive approach. If you're reacting to service problems with chillers and you really have no forewarning, this is kind of how it works today. And maybe this picture that I'm going to paint, you know, might resonate with some of you out there. But let's think about how it works today. If you have a problem with a chiller in a building, let's just say it's, in this case, it's a single chiller building, and the chiller goes down, unless somebody's out there looking at it and watching it. Sometimes it can go off and you don't notice it until chilled water temperature starts to climb, the building starts to get warm, and then somebody says, hey, we got a problem. So the first thing that happens is, well, they check to see, well, what's causing this, and someone goes down, they look in the mechanical room, find out the chiller is actually off, and trying to determine what caused it to go off, but not really sure. So the first thing you do is, in most cases, you call a service provider. Service provider comes out, has to get into the building, gain access, gets into the building, starts doing some troubleshooting, goes down, finds out that the machine actually went off on a safety. And in this case, I'll give you the example of going off on low refrigerant temperature, which typically is an indicator that maybe the machine was low on refrigerant. So they have to figure out, okay, it was off on refrigerant temperature, and it's a very hot day. You try to restart the machine, very difficult to get it back up and running when you've lost control of the building, chill water temperature's climbed. Takes quite a bit of time to get that done. And then you find out after running it, you've got a pretty substantial leak. And you know what? That leak is in a place where it really takes 2 people to get the repair made. And so you got to call the shop and get somebody else out, get a second set of hands, have to take some rigging into the building, repair a leak, get some refrigerant. Oh, you got to go to the supply house because there's not enough refrigerant on hand. So all this is taking time, and it's not really wrench time. It's basically trying to get organized to make the repair. So that could take 24 to 48 hours to make that repair. Once you're up and running, then the system is restored. But just think about all the downtime and all the, you know, the non-real valuable time that you spent trying to figure out what was going on with that machine.
Yeah,
that's the long and costly reactive approach.
Yeah, it's not really anybody's fault. It's just kind of the way that, you know, service has traditionally been performed on these pieces of equipment. You know, but you're doing inspections. So why does this happen? And part of it is because 89% of all failures are random. So even though we do inspections on timed intervals, we know that most things don't fail on a timed interval. We can't predict when they're going to fail just by looking at it over time. And so leveraging these predictive and Internet of Things technologies can help you provide a more complete picture of chiller health and performance and help you avoid some of those random failures that cause that disruptive, you know, expensive emergency in the first place. And so we've got some of these things listed on the slide: the vibration analysis, oil analysis, refrigerant analysis. all other types of analyses, as well as our Internet of Things technologies. And we're going to take a look at each of these in more detail.
Yeah, happy to do that, Julie. You bring up the different predictive technologies, and some of these have been around for many years, others are relatively new. And when you get to the very end, we're going to cover something in the area of IoT and that is, substantially new. Now, vibration analysis, gosh, it's been around for a long time. In fact, we've been analyzing machines for about 25 years at Johnson Controls. But there's really two types of vibration analysis. One is the snapshot, and that's where you actually go out with the data collector and you do vibration analysis of a machine under a load in a one-time event. Now, you may also do continuous vibration monitoring. That's actually popular in a lot of different businesses out there where you actually are doing online analysis of the equipment, and through, again, Internet of Things is a way to do that. Now, what we use vibration analysis for, we're looking for rotating equipment where there could be a problem: bearings, shafts, motor, compressor, fan, gears, impellers, shivs, belts, couplings, alignment, and imbalance. In the frequency that we do this, it really depends on how that machine is used, and really mission critical too. The machines that are more mission critical, we typically recommend you do it more often. And then of course you have machines that run year round, sometimes 24/7 year round. So you're going to have different frequencies on when you do vibration analysis. But what it does, it gives you an indication of when you may have to replace a bearing or a component. One example in the graph we show is that, the life of a bearing is extended when the mils per inch of vibration is reduced. You have vibration, it's going to take longer to do that. Next slide. Another tool that we use is oil analysis, and spectrochemical oil analysis is used on a periodic basis to look at wear metals, to see if your additives that you've got in the oil also are breaking down. We look at the physical properties. We also look at particle counting and using the ISO code for that. John Kukler is with us today. We were talking about that earlier today. John, how does ISO used in oil analysis?
Well, ISO is really the cleanliness of the oil. There's various codes that ISO has out there as standards. So a manufacturer will pick an ISO code to determine what the lifetime of a bearing is going to be, for instance. And if that oil is not to that cleanliness level, it's not going to maintain or reach its expected life, for that bearing in that machine. So it's pretty critical to make sure that you're maintaining the design cleanliness of the oil, and that's what the ISO code has to do with it.
Right. Very good. Yeah, and we use oil analysis to identify component wear, right? We do that. We also use it to extend the life. And quite frankly, today, a home run for all of us is if we don't have to change the oil, right? We don't want to change it because two things happen. One is it costs money. The other thing is that oil has to be disposed somewhere, right? So it ends up going into either hopefully a recycling, but in some cases it has to be dealt with.
And it's technically an intrusive task.
Right.
This could just induce more problems in the machine by doing it.
Right. So we really want to keep the oil in there as long as we possibly can, but we have to make sure that it's at the level that it's going to still continue to protect the machine. So your bearing life, I mean, if you look at that, your filter micron rating, if the finer the material and the higher the rating on the micron, then basically you're keeping that oil clean, right, John?
Right, exactly. Just the higher the rating on the filter, the better it's going to do at keeping the contaminants out of the bearings. So almost related to the ISO code is just making sure you're maintaining a certain cleanliness level of the oil.
Yeah. We also want to make sure that we don't have a high percentage of water in that oil too. In your low pressure machines, you do take in air. If you have a small leak, and with that air, you bring in some moisture, and that water can end up in the oil. And again, I think we know that's not a good lubricant. We want to get it out of there. And it also can create acids for you. So that's oil analysis. The second one of type analysis, fluid analysis, is refrigerant analysis. That's also very helpful to look for things like acid or moisture in the refrigerant, or even the high boiling residue. John, you're talking about the non-condensables. Is it one of the things you pick up when you're looking at refrigerants, right?
Yeah, non-condensables or oil is actually considered a non-condensable. Of course, if you have oil in your evaporator, you lose an efficiency on your machine too. So you want to make sure you maintain a pure refrigerant in the condenser or an evaporator, I'm sorry.
Right. Yeah, and we use refrigerant analysis to identify, like you said, to make sure that the efficiency is where it needs to be. These low pressure machines, when they do get leaks, it does take in that, again, the unwanted, the non-condensables moisture, and the purge units have to make sure it gets rid of it. So we want to make sure that you're testing the refrigerant from time to time from that standpoint. Usually about once a year on refrigerant analysis, right, John?
About once a year.
Eddy current testing and infrared testing. Let's start with infrared. I mean, it's really one of the best, most cost-effective, non-destructive tests you can do on an electrical system. It really is, because with a good infrared camera, you can look at your more critical equipment, your starter panels on these chillers, and it's going to identify the big enemy, and that's heat, right? When you have heat in any kind of electrical system, you have the potential for catastrophic failures. Electrical connections, bad fuses, corroded connections, loose connections, damaged switchgear, unbalanced loads, and open circuits. So it's a very, very productive way and very quick way to determine if you have problems. On eddy current testing, that's been around for many years, but it's still very, very relevant with these machines. And the condenser and evaporator tubes are subject to defects over time. Things like wall thickness can be reduced by acid or corrosion. You can have broken or cracked tubes. You can have pitting or freeze bulge. And sometimes a machine will freeze, you didn't even know it, but it will bulge right around the support sheets or crown sheets. And that can, at some point, create a leak as well, or support wear. And that, again, that's the support sheets. But both those, eddy current and the infrared, are also periodic inspections that you want to do that are non-destructive. Motor current analysis, John, you and I were talking about this earlier, how important that is when you're looking at motors and some of the things that can go wrong. Can you give some examples of that?
Yeah, I mean, examples that are shown here, such as open rotor bars, easily detectable by monitoring the electrical signals from the motor itself. And then, electrical connections, loose or broken, or, connections that aren't torqued properly and stuff can be detected. The motor current analysis is really the equivalent of like vibration analysis, but on the electrical side of things. It's the best way to diagnose electrical related problems.
Yeah, and we use MegaTest, the high pot, and surge and motor current. The high potential is more of a kind of a stress test, right, John?
Yeah, it's a kind of a destructive test. You got to be a little bit careful on this one. You got to have your ducks in a row and make sure you know what you're doing on that one. But it is somewhat of it is technically considered a destructive test. So if you have any inkling that you have a motor problem or a winding problem, you probably don't want to do that one. You probably just want to get it fixed. Yeah,
but you certainly want to know about it when it's not in full operation. Exactly. So that's the advantage of doing it.
Right.
Yeah.
Right.
Yeah. Good stuff. Next slide. So when you think about all these different things that we've looked at, not all analysis are equal. Things to watch for, generic rules for machines. When we say that is that it's not necessarily every machine is the same. We have different conditions that these machines operate in. In fact, John and I were talking about the fact that when you even do vibration analysis on a machine for the first time, that baseline may not even be correct. The baseline may be way off. So you want to make sure that it's
recognizing
correct.
What's good and what's bad, and having the experience ahead of time to do that. I mean, we put a lot of value in having experienced technicians that know how to repair machines. It's the same thing when you have a vibration guy looking at things. Has he seen this kind of machine before? Does he know how to look at it? Does he know the internal makings of the machine that he can properly diagnose it?
Right.
And how many times has he seen these things before?
Yeah, excellent, excellent. So the next slide we have is we really are showing that the predictive testing itself is done by a testing provider, and you have to really be careful because HVAC equipment is actually quite different than a lot of the equipment that we do this testing on. So you need to make sure that this is within whoever's doing the testing, if it's within their expertise. Do they really know chillers? There's a lot that go on with chillers that don't go on with other machinery. Also, a centralized approach. Who's doing the analysis? What are you comparing that information with? What kind of database do you have? How many signatures have you taken? And from a statistical analysis, you want to look at the algorithms or methods they use to analyze that data. Very, very important. And in summary, on vibration, if you look at it, Johnson Controls, over the last 5 years, we've analyzed almost 30,000 machines, and many of them are York, of course. That's our brand, 9,000 YKs alone. But we also have Train, Carrier, and Frick and McQuay machines. But unlike when you're looking at these machines, we also have established a patent, for amplitude. John, can you share what that's about?
Yeah, and that has to do with, how do we use this data? We've done 30,000 the last 5 years, but this program's been around over 25 years. Mm-hmm. So we've really tried to leverage the use of all this data and information. We've been able to develop a patent system around how do we develop alarm limits on these kinds of machines. It's like Dave said, a chiller is not the same as some sort of a spindle machine, die casting spindle machine or something like that. They're different machines. You can't treat them the same. So that's why we work diligently to leverage this data and use it for that reason, to actually develop something unique around a chiller.
Yeah, very good. Thanks, John.
So the last piece of our picture, in addition to all the great tests that Dave and John just talked about, are Internet of Things technologies. And it's really the final piece of the puzzle to get this complete picture of your chiller health and performance. And so, what's wrong with this picture? What do we see in this picture that may not be right, Dave?
Well, I'll tell you what, it's certainly not safety, because we see that the technician's got a hard hat on, got the gloves, got the safety glasses. I see the blue bag. So definitely even probably steel-toed boots on. So that part looks good. So what is it?
It's the clipboard.
Oh, okay, the clipboard.
We have these high-tech machines with all these sophisticated electronics in them, and yet for many of our customers, they're still sending a technician around to copy down values out of the panel and store them in a binder next to the machine, so they have long-term storage of the data. And so we're interested in understanding a little bit about how you guys log your chillers. So Ann?
Yes, thanks, Juliet. So yes, we do have a second poll for everyone to take a look at and share their experiences. And it's right there on your screens. And it's asking, how often do you log your chillers at your facilities? Is it once a month, once a week, once a day, more than once a day, or never? So please take a moment to share that with us, and we'll show the results again. Okay, so the results will be up in a moment. And let's see. Once a day, 26%, very nice. So 19% once a month, followed closely by once a week. More than once a day is 22%. So, and never is 17%. So it's across the board there. Thank you for sharing that with us, and back to you.
Excellent. And that's pretty consistent with some of the research that we've done on some of our customers and influencers that we reach out to on occasion to gather this kind of information. And over 50% of the folks that we surveyed logged their chiller at least once a day, and that was pretty consistent. I think we had 19 and 22% said they logged it either once a day or more than once a day. And 60% of those folks that we surveyed said that they use paper and pencil to log their chiller data. Less than 10% of them are using a mobile device or tablet. And 44% of them are storing the information in a binder in the equipment room. So even with all the technology that we have, we're still sending guys with clipboards around and trapping that valuable operating information, those keys, those clues to understanding what's actually going on with that machine in paper, in a binder next to the equipment, where somebody has to be on site and manually looking at it to derive value out of it. So how do we leverage technology to change this picture, right? And so one of the things that we've been doing here at Johnson Controls for about the last 3 years is that we've been connecting our chillers to a cloud-based analytics platform. And our system uses Microsoft and Azure Analytics Cloud. And this allows us to do a couple of things. First of all, if we do have one of those critical emergencies, like the emergency that Dave talked about at the beginning of the presentation, those alarms are sent directly to our remote operations center so that we can alert somebody in our field organization to speed help to that customer right away. And second, all of that valuable chiller operating data gets sent to that cloud for storage and analysis. And that does a couple of things. First of all, it makes that data accessible to customers and our field technicians so that they can diagnose problems faster. They can identify the parts that they need and get a better picture of what's going on with that chiller to start being more proactive and less reactive. And the other thing we can do to help them with that is use analytics, the power of the cloud computing, to produce predictive reports similar to the predictive testing that John and Dave talked about before, but based on the data. And so we'll talk a little bit more about some of the ways that we do some of this fault detection. And there's kind of 5 methods here: alarming, rules-based fault detection, performance indexing, statistics-based fault detection, and then a combined approach. And so when we think about alarming, that's, pretty common. And I think most people are familiar with alarming from their day-to-day experiences with their building automation system. And alarming is great for identifying critical conditions that need immediate attention. And so that's one of the reasons that we send those critical alarms that our chillers produce right to our remote operations center, who monitors them 24/7, 365, because they need somebody to receive them so that they can take immediate action. So that's alarming. Rules-based FDD is kind of, I think of it as sort of alarming on steroids, right? It really establishes some guardrails or some rules around expected performance. And it helps you identify non-critical deficiencies. So as one example of guardrails is to set high and low parameters for a particular value and identify when that machine drifts outside of those parameters for a certain period of time. The challenge with rules is that they have a limited ability to adapt over time. So as the machine ages or as conditions change, it requires somebody to go in and manually change the rule to reflect the new performance or operating conditions of that. But they still can be very effective and have a valuable place in fault detection and diagnostics. The third way of fault detection diagnostics is performance indexing. And, performance indexing really allows you to simplify and present complex data into a highly usable format by normalizing data in a way that people can easily relate to. So some examples are, color coding something red, yellow, green, or rating something from 1 to 100 in terms of performance. So it's a relative ranking that indicates the performance. And again, performance indexing can start to help you, identify when things are working well, but also start to identify and provide an early warning before you get an actual fault or alarm or a rule triggering. So it's a way that helps you identify these early conditions and also quickly triage a vast amount of information and understand where to focus your attention. And then the final specific FDD that we have here is statistics-based FDD. And we talked a little bit about this with regards to the way we do our predictive testing. And we can also do this with operating data as well. So comparison to prior operation, right? So you can see if the banana started out yellow and turned black, well, we know that something changed there, and we have to find out why that banana is starting to go black. Peer group analysis, or as I like to call it, the Sesame Street algorithm, is which of these things is not like the other. So identifying an outlier in a group of like objects can start to point you again, to train your attention on it. Now, one interesting thing as you start to think about applying peer group analysis to chillers is that any one facility, unless they're very large, usually doesn't have enough chillers to do peer group analysis. When we start to aggregate the data from many, many facilities, and we have over 3,000 chillers connected to our system, now you can do some of these advanced statistical-based functions like peer group analysis on pieces of equipment that any single facility likely would not be able to do.
I would add too that even 1,000 of the same model number, not just the chiller, the same model number under similar conditions can be analyzed to gather all that data.
Absolutely. Right. And finally, statistical models. So again, creating, as Dave likes to call it, a digital twin of the machine, and then comparing the actual operating data to that digital twin. So we see our nice ripe apple, and we've got a nice ripe apple next to it. But if that apple next to it had a bite out of it or a wormhole in it, then that algorithm will be able to pick up that difference between the real operating data and the statistical model and be able to flag that difference and identify it and bring it to someone's attention.
And I'd say the beauty of the digital twin is too, you can do what if scenarios. And if you want to tear up the digital twin, that's fine. Just don't tear up the real machine if you wanted to test some different things.
Yeah, if you wanted to see how far you could push your chiller
Push the envelope. Right.
in terms of operating conditions, you could do it on the digital twin before you did it on the real life machine. So finally, you know, the best of all worlds is using each one of these methods to provide to its strengths to provide the best outcome. So, you know, alarming definitely is great, you know, using it to identify those critical issues, leveraging rules to identify those deteriorating conditions that can eventually turn into those emergency situations that are so costly and time consuming, and head them off ahead of time. Performance indexing to help you plan which of these machines needs my attention first, and statistics to adjust rule and performance thresholds, and also to identify those outliers that may not be detected through these other routines. So, so again, we think that, you know, there's horses for courses, and a system that combines all of these approaches and all of these technologies is really the best way to get that total picture again of your chiller performance. So Dave, take us through how this might look now as we start to apply some of these predictive and IoT technologies.
Yeah, happy to do that. You know, I talked earlier about the costly reactive approach. This is the corrective approach, using these predictive, like Juliet said, and some of the tools that she actually went through. So let's just take us back to our scenario. We had a chiller that was running, had a really hot day, right? And that machine went off on a safety because it loaded up all the way, didn't have enough refrigerant in it, and it went off on refrigerant temperature and caused a big disruption. Well, let's see if we do this a different way. Let's say that did happen, but instead of someone rolling the truck immediately and sending someone to the job site, once that call came in, they were actually alerted right away, so that you knew the machine actually went down long before anyone in the building even noticed it, right? Because they're getting that alarm. And they also have a chance to look at maybe what happened to it. So in this case, they went and looked at the trends, and they could see right away this machine was running with a low level of refrigerant in the condenser, indicating that the machine was undercharged. And then it loaded up, had a hot day, and it went off on a safety. So it gave them a clue. They got a clue right away, perhaps what happened. So when the technician's on the way to the job site, the technician is notified by the service manager, let's get some refrigerant on your truck before you head out there. And so they get to the job site, have some refrigerant on hand, and perhaps, you know, it can speed up the inspection. That doesn't help because you identify that a second technician might be required, and that IoT is not going to help you there. But what if it was condenser tubes? And you could see the tubes are getting dirty over time. And then, you know that you need to send a couple of people because you have to take heads down on a machine, and you need a tube cleaner. So there's a lot of things you can do to prepare if you have data before you send someone out to the job site. So we call it fast forwarding the process. May not be able to completely eliminate downtime, but at least you have some clues on what's needed to make the repair before you get there. And then even better is the cost-effective proactive approach. And what we're doing here is that the dashboard of this machine is being looked at every day. So you have multiple machines. A service manager is looking at the dashboard, and all of a sudden they start to see, long before this machine went off on a safety, that there's a potential problem with this machine. It looks like it might be low on charge. And oh, by the way, the day that they're looking at it was actually kind of a cool day. So they were able to at least indicate that maybe we had a problem. So you contact the customer. Customer is notified that we potentially have a refrigerant problem. And so they're able to go out and maybe do this repair on a time when it is very, very convenient. In other words, maybe late in the afternoon on a Friday, or perhaps when it's not going to do any disruption to the building. And I guess most importantly, you didn't empty out a lot of refrigerant with a small leak. So again, that's the difference between the reactive approach and using these tools.
Yeah, and adding those predictive technologies like oil analysis, vibration analysis, refrigerant analysis just gives even a more complete picture to the data that the technician is looking at on the screen through IoT.
That's right.
So what could we expect if we could take a more strategic approach to maintenance? And we've been doing this for about 3 years, combining our predictive testing, our Internet of Things technologies. And what we've seen is, first of all, in the machines where we have applied some of these technologies, we see a 66% reduction in unplanned or emergency repairs. So 66% reduction in events that actually shut the machine down. The second thing we see is a 65% reduction in mean time to repair from the time we're aware of a problem until the time that problem is resolved. And really having all of this information does two things. First of all, it helps us really do a better job more proactively identifying conditions that could shut the machine down and correcting them, that proactive approach before they actually turn into that costly, disruptive emergency. And secondly, it provides us the information when there is a reactive situation, and we know they always happen, to speed that time of recovery up quite a bit so that the disruption and the cost can be minimized. And then finally, at some point, we're going to have to think about when do we start thinking about replacing chillers. Now, the average life expectancy of a chiller is between 20 and 23 years, depending on what kind of chiller you have. However, in some cases, you may either want to accelerate that time frame, so do it sooner than that, or you might be able to extend that time frame, so do it after that, because you've been doing some of these other things on your chiller. And some of those factors that play into that decision are the chiller reliability, the availability of refrigerant, the energy efficiency of that machine, the maintenance costs, and finally, capacity. So let's talk about each one of these things and how we optimize that decision to think about starting to think about replacing a chiller. So first is reliability, and obviously the number one measurement is your downtime. How much downtime are you experiencing? But a second way to look at it is the ratio of your planned to unplanned maintenance. So as your ratio of unplanned maintenance starts to creep up from 2 to 3%, which we think would be pretty good ratio, up into that 5 or 10%, then maybe it's starting to cost you more to have this machine in place from a maintenance standpoint than it is to start thinking about replacing it.
Yeah, and from the standpoint of extending the life and maybe getting a lot more life out of it than really even ASHRAE would ever say, is using these tools we talked about. To the extent that you've got a good predictive program, incorporating some of the items that we had in the IoT technologies, you may be able to go long past that ASHRAE life.
Yeah, and if you don't have that, those sorts of things, and if you're not doing adequate maintenance, that may actually accelerate your time frames. You may end up replacing that machine much sooner. Absolutely. So second is refrigerant availability. So here, we're looking at the phase-out date of that refrigerant, and certain refrigerants, the HCFCs, have a set production elimination timeline where they can no longer be produced. Other refrigerants like HFCs do not have a phase-out date. There is a phase-down date. It's not a production elimination. It's, however, in 2024 in the U.S., no new equipment using those refrigerants can be sold in the U.S. So the refrigerants themselves, they will still be produced and available. And why is this important? As the refrigerants are phased out, they become more expensive and they become harder to get, right? So some of the accelerators you may think about is to maybe replacing that piece of equipment sooner than that 20 to 23 years is the lack of availability and cost of those phased out refrigerants, as well as if your company or enterprise has any specific sustainability policies around refrigerants and their impact on the environment.
Yeah, and from an extender standpoint, the way you can get it to last longer is through containment. What are you doing to use these predictive tools to make sure that you don't have any leaks? Because again, refrigerant's expensive, as Julie had said. It's also damaging the environment. To the extent that you can keep these machines tight, use the tools to indicate when a small leak comes up, then you can take care of it before it becomes a major problem.
Absolutely. The next one is energy efficiency, and this is measured through energy costs based on real-life performance. And we know that most chillers operate between 30 and 65% of the load for the majority of the time that they're running. And so that's really the way you've got to evaluate it, the machine efficiency, rather than just looking at the full load efficiency rating of a machine. So some things that might make sense for you to shorten that time time frame to replace that chiller might be if you find a very efficient machine that, as you do the math and you look at the savings, it has a very attractive payback that would make it make sense for you to get a new machine that has some energy benefits as well. And there's utility rebates also that can be leveraged to improve those paybacks and make it more attractive. The other thing to think about, right, is if you have high energy prices or if you're seeing dramatic increases in energy prices, it may be time to look at this again, because those increases in energy prices can turn something that didn't make sense the last time you looked at it into something that makes sense now.
Yeah, and I wish we all had a crystal ball to know whether energy prices are going up or down. I think most cases they go up, but but if they did have a decrease, then it might make you want to think about keeping your chiller longer. But again, these predictive, these IoT technologies can help you make sure the machine's running as efficiently as possible, right? Clean, and being able to analyze that. And I think also there's some optimization programs. You could put variable speed drives on machines, make them a lot more efficient, not have to change out the machine. So there's some different techniques that you can use to extend life.
Absolutely. Some of those things like variable speed drives and different control strategies help you get more out of your investment and can help you actually improve the efficiency, not just of the chiller, but of the overall
entire plant. Right, exactly.
Then finally, maintenance costs. So again, one of the things we like to look at here is your total maintenance costs and the ratio of that towards the replacement value of a new machine. And so one of the things that might accelerate that as you look at it is if you have new technologies that actually have reduced maintenance requirements. So we know a lot of our new magnetic bearing machines are oil-free. They don't really require any vibration because those bearings they're frictionless bearings. So there's some real advantages, when combined with some of these other factors to thinking about a new machine like that would significantly reduce your overall maintenance costs.
You can extend the life of the machine too by, keep it around longer, because some of the IoT tools are more cost-effective from a maintenance standpoint. You can actually do more with less, and that'll help you maybe decide to replace that machine just a few more years later if you keep those maintenance costs in check.
Absolutely. And then finally, capacity. And this is really, load requirement of the facility, something that often you don't have control over, and some things that might accelerate this might be increases in occupancy or heat producing equipment or expansions or renovations that add square footage to your facility.
Yeah, and I tell you, a lot of people don't think about it this way. When you do energy lighting retrofit, one example, in a building, it significantly reduces the load. So, you think you may have to put the same size machine in, or you may have to add the capacity, but you think about what you've done to your internal heat load with some of these retrofits, it can significantly reduce the cost. And you don't need that additional capacity at that point.
And we talked about chiller optimization and how that can improve the efficiency. Maybe you get more capacity out of the machine.
Right.
So really, what you need to do is take each one of these pieces and look at them as a holistic picture to say, what impact is each one of these things having? Is my chiller nearing its life expectancy? Do some of these other things like maintenance costs, refrigerant availability, efficiency, or reliability tip me over the edge? Or have I had some sort of a significant event that requires me to add more capacity and potentially replace this chiller?
Yeah, and any good life cycle analysis, whether it's from the very beginning or even 10 years into the life of a chiller, should include all these components, because these are the decisions that you need to make. And if you do a good financial analysis of it, I think you'll make a good informed decision on whether to replace or not.
Absolutely. So we'll wrap up here. We'll have some time for questions. So in summary, I think we've shown you how predictive and IoT technologies can really help provide that complete picture of chiller health and performance and help you get the most out of your investment in that piece of equipment. And using that centralized statistical approach to predictive testing really brings that expertise and that technology to getting the best results you can out of that testing. And then adding in IoT technologies really helps put that critical operating data into hands of operators and technicians and really help improve operations and diagnostics and really help minimize or reduce downtime through those emergency events. And we talked about the 6 key factors in replacement decisions and how predictive and IoT technologies can really be used to extend your replacement timeline and help you get more out of the investment you've made in your chiller.
Great. And with that, I think we wanted to open up for questions. We'd love to hear from you. We've got a few minutes here left that we could, between John, Juliet, and I, we can handle.
Great, thank you. Thanks, Dave and Juliet and John. So yes, we do have some time for some questions and answers. So let's see. We'll start with this. Can you talk about what is the difference between using a system like this, the Internet of Things system and approach, versus connecting chillers to a building automation system? What are some of the differences there?
Yeah, absolutely. So, when you think about your building automation system, its primary purpose is to operate the equipment in your facility. And so typically when you connect your chiller, you connect, maybe at 20, 30 points, the points you really need to operate that chiller and also give you some key pieces of information to let you know how that chiller is operating. And it's not set up to have storage capacity for lots and lots of trend data sampled at high rates of frequencies, or to store that over long periods of time. When we connect the chiller to the cloud-based analytics platform, that is a direct connection from the chiller to the cloud. And because the cloud has, for all intents and purposes, really infinite storage capacity, we just take every point that chiller is generating from the time it is connected, and we keep that in the cloud as long as that connection is intact. So, and we sample those points at a pretty high frequency, every 1, 5, or 15 minutes, depending on how often those values change. So you really get a lot richer access to that information, and also it's more accessible to more people because it's in the cloud and you don't have to access your facility's network. It's a lot friendlier to the IT people because you don't have people diving into their systems, so to speak. The other thing it does is, your building automation system isn't really set up with the capability to do some of these advanced statistical type analyses. And even if you had the smarts and the wherewithal to program it in there, I'm not sure you'd want to take the processing power that it would take to do those things away from the primary purpose, which is operating the building. So in the cloud, we've got, again, tremendous processing power, tremendous access to data, and so we can run these statistical analysis that really provide those key predictive factors that allow you to head off those emergencies, rather than a DAS. We're pretty much monitoring things so that we know when there is something to react to.
Thank you. Thank you.
Great. Thanks.
And along those veins, just a question about security concerns. You had mentioned the cloud and how that obviously gives a great capacity for data and other advantages. But can you talk a little bit about just the security that everyone is concerned with these days when it comes to these types of things? How has Johnson Controls addressed that, or what does that entail for the facilities person?
Sure. So, I can't speak for other systems, but our system, we try to optimize it to be very IT friendly. So a couple of key things. One is it's a one-way outbound only connection to the cloud, so there's no inbound ports. The second thing is the data that we send out is encrypted. So if someone were to intercept that data coming out of the building, it'd be difficult, if not impossible, to actually decode it or read it. And then the other thing is, if we want to,
if you want to do it without the network,
yes,
put it on a modem too. Yeah.
Thanks, Dave. I totally just lost my train of thought. Dave just picked it up. Yeah, absolutely. If you want to isolate it from your company's network, we can supply a cellular VPN connection so that it's just a direct connection to that chiller. It doesn't touch any other parts of your network.
Yeah, so it's just an added cost of a modem and added cost of a data plan is what it comes down to.
Yeah.
Right. But some people feel more comfortable with that, and you certainly can go that direction.
Yeah, and we do find that, many IT departments feel perfectly comfortable having our system on their network because of the way we've got it set up.
Right.
Great,
there was
thank
a
you.
question out there about vibration, right?
Yes, there is, Dave, and that is the current vibration monitoring technology is expensive, asks one attendee. So when do you all suspect that the costs will be coming down, where facility managers and executives can monitor a 1 horsepower motor, for example? Can you comment on that?
Yeah, industry right now itself, the vibration industry is going through kind of a revolution. And so it's in the process of kind of being turned over at the moment. And traditionally you had 3-4 primary OEs that provided the hardware, software, whatever. And you're right, it was quite expensive. It was hard to get into the business, required a lot of training. But the market is really kind of changing quite dramatically now with the advent of smart devices and things like that. And, off-the-shelf technologies become really inexpensive. And so I foresee in the fairly near future that you're going to see it becoming very cost-effective, both from a hardware standpoint, software standpoint, and somewhat from a diagnostic standpoint, that it's going to begin to become much more cost-effective for our traditional markets here in HVAC business. So we are currently working on various projects related to that, as a matter of fact, and I wouldn't be surprised in the next couple of years that you aren't enticed and somewhat find a few new developments quite interesting and to your liking in that area.
Thank you. Thanks for answering that. So let's see, we have a question about, we'll jump back to preventive maintenance and FDD. So how do you all differentiate between preventive maintenance and fault detection and diagnostics? I know obviously you talked about both of those approaches. So how do you differentiate between those two?
Well, preventive maintenance is really maintenance on a task or a frequency. It's based on, most of the time it's calendar based. When you use FDD, and the way we do it at Johnson Controls, much of the FDD is actually on board the equipment. It's in the panel. It's in what we call the smart panel, and we always encourage people to, develop more smart panels. So that FDD, between that and what the cloud storage and calculations can do, we could provide that. I think the other question was around, it was FDD. Yeah, it was FDD and difference between two.
And I think really, you want to use them both to their best advantage, right? You use routine maintenance to do some of the routine things that we know have wear schedules.
Right.
And
greasing a bearing, for instance, you can't really change the time-based. That is time-based. It's going to always be probably time-based.
And then we can leverage the FDD both in the IoT as well as some of the predictive testing to help us. The great example was the oil change that Dave and John talked about. Do oil analysis, and if the oil doesn't need to be changed, don't change it. It doesn't have to be changed on a schedule. And same thing, with IoT, we can help right-size the investment you make in maintenance based on the data that's coming from the machine and the fault detection and diagnostics that we perform.
I would say too that FDD, there's a balance between the cost of being able to get the information to the dashboard and to the cloud via sensors. There's some equipment where equipping them with sensors is just not cost effective, right? So that's going to end up being more PM versus IoT.
Great, thank you. And we have time for about one more question, and we will dive into the fact of existing systems and perhaps I should say older machines. And we have an attendee asking, I'm sure in my older machines, those points of data for monitoring with the IoT system you mentioned do not exist. So how painful is this upgrade is the question.
That's a great question. And, I do a lot of seminars. We talk about this a lot. I think back 30 years ago, and I can go back 30. I can go back 35, actually. Maybe even longer than that. But I would tell you, when I think about what we used to have in the way of points on a machine, even before we had smart panels, we might have 18 or 15 points that we would even log, physical log. Today, we have upwards to 200 points. So the difference between an old machine and a new machine, the older machines don't have the smart panels. So it is very costly to do those. You have to actually put sensors on the machine. Very, very difficult to do. But, if they have the smart panels and the new machines, it's very cost effective. So when we do an upgrade and it's an older version machine, it's always kind of a special quote is what it ends up being. We have to actually do some investigation in the machine, what we can actually pull through and what we can't.
That being said, modern machines, so I would say anything 10 to 15 years old or and forward, most of those have some level of degree of smarts in them. So if we're not going back to the dark ages when Dave was starting out in the business.
Well, it wasn't quite the dark ages, but it was a while back.
But 10 to 15-year-old machines, they usually have enough smarts and data that the panel is producing.
Right.
We don't have to add any additional equipment to that machine. We can
Yep.
take the data out of the machine. Now, are you going to get as robust of diagnostic capability as with, you know, a newer machine? Maybe not, but we still get enough trends and information on that machine without having to retrofit additional sensors or information onto that machine.
And one option always exists too, and that's to upgrade the panel. You know, you can actually put a new panel on machines, and that has been done in many, many cases where you upgrade to more, you know, a panel that has FDD built into it.
Absolutely.
Great question.
Great. Thank you, and thanks very much for that, for the robust answer. I guess we'll wrap it up there. I want to thank everyone, all our attendees, for your attention and your questions, and thank you again, Dave and Juliet and John, for the presentation, and to Johnson Controls for sponsoring the webinar. A recording of the webinar will be available online at facilityexecutive.com, as well as at the Johnson Controls website, which is johnsoncontrols.com. So thanks again, everyone, and have a great afternoon.
Great. Thank you.
Thank you.